Nucleosynthesis, the formation of elements in the universe. So, let's talk about nucleosynthesis, which is the formation of elements. There are main types of nucleosynthesis. There are Big Bang nucleosynthesis, stellar nucleosynthesis, and supernova nucleosynthesis. All these three related to the formation and evolution of the universe. Let's start with the Big Bang nucleosynthesis. Early after the Big Bang, as the universe continued to expand and all the first elements were formed, these were just the nuclei of elements. They were not whole atoms, meaning they were ions. They were missing their electron. The formation of the nuclei of hydrogen and helium happened about 3 minutes after the Big Bang. Now, the first elements to form were hydrogen, helium, and a few other trace elements. Eventually, after were cooling and expansion, the hydrogen and helium nuclei were able to attract and hold onto electrons. This allowed them to form whole neutral atoms as we have on our periodic table today. Whereas the formation of neutral atoms took until about 300 years after the Big Bang. As this matter formed all 3 minutes after the 300 years. After the Big Bang, there was a K-ration that happened. There was 75% hydrogen and 25% helium. And this same ratio of hydrogen to helium is seen today in our universe and serve as a key evidence of the Big Bang. But it is also a key point where elements were formed in our universe. This formation of helium, hydrogen no longer taking place in large events. And in our universe, so basically all of the hydrogen and helium and the universe came from Big Bang. The next major point where elements are formed is stellar nucleosynthesis, and this takes place through the process of form in the center of star and is responsible for the formation of all of the elements from helium all the way up to iron on the periodic table. And the formation of these elements take place in the center of star in the process called fusion, where it is extremely hot and where there is an extreme amount of pressure. This process matches the nuclei of smaller elements together to form larger one. Let's go through the general process that takes place. This young star use the elements pipes and helium to fuel fusion in their takes place and star were formed. These heavier elements, young star use the elements pipes and helium to fuel fusion. In their words, now the smaller nuclei such as hydrogen and helium are smashed together. In the center of the stars, at such high temperature that there is enough force to stick them together. Extreme temperature are required to complete this fusion process in a star. For example, our sun has a core temperature has up to 15 million degrees Celsius. Temperature like this are required to complete this fusion process. This is how star, through the process of fusion, can form heavier and perform elements. As a young star use up all the available hydrogen, helium in its heart, it will eventually collapse on itself. This causes an increase in the amount of temperature and the amount of pressure found in its heavier and heavier elements. Now, this process continued over and over again until a star with enough force can use smaller fusion. Iron now, those stars can use elements heavier than iron. This is the limit, and if there were not atoms process of nucleus or another way to form heavier elements, we would not have any elements heavier than iron. Together, stars cannot form atoms heavier than iron because there there are not enough neutrons in their core. The rest of the heavier elements that we have are forming in the process of supernova. And in the drawing sample goals now, their elements form during the very violent explosion that happens in supernova as the start turns out of all the other fuels available to it form which it can make heavier elements form. What you complete in the process of fusion, it will eventually get on itself, which create a heavy element back or shock was which pursue all of the elements that are inside the one of the star, run into the space surrounding during a supernova explosion. There are two K characters, the atom for heavier elements, then now to be made, and these two characters don't exist anywhere else. There are two characters that are extremely hot temperature, and an element's neutron. Abundant neutrons, neutron supernova starters can reach temperature of 100 million degrees Celsius. This is 6,000 times hotter than the core of our sun. Also, supernova explosion have extreme the